Hey, this is Stereo Police, back with what I hope to be a final, absolute final video regarding my speaker cable, damping factor, cable resistance, etc. series of videos. Now, what you're looking at here is a really poor example of what a workbench ought to look like. However, I just finished, you can see all these little clippings here. I just finished completing the building of my 4 massively paralleled, ugly as heck speaker cables. And that's what you see, and I'll explain to you what you're looking at in a minute. As far as this is actually, if you can see through the spaghetti here, this is actually a test setup involving my Keithley, involving a power supply and a DVM hooked up as an ammeter. And I'll explain that in a minute. So what I want to do is, and I thought I'd make this video, I guess I get encouraged sometimes by certain comments that people make, and somebody, a YouTube user recently said that it was one of my videos where I was running some very simple mathematics. I think it was the first damping factor video maybe, and he said that he was going to have his son watch it. His son's into audio and it's a good learning thing, and that sort of thing. So, you know, I figured I'd go ahead, and since this involves some rudimentary, very, very rudimentary, almost elementary school math, but it also involves the physics of the situation and some measurement, and, you know, it's a little quasi-scientific thing here. I'd go ahead and make a video about this, and what I'm making the video about is how to measure the resistance of speaker wire given that it is so incredibly small. Your typical digital voltmeters, and even your analog or vacuum tube or FET analog meters, they won't measure resistance down to below 1 ohm, and these speaker cables are well below 1 ohm. They're down in the orders of a hundredth of an ohm, or 1/1000th of an ohm, and there's no way you can get an accurate measurement out of a DVM, at least an ordinary DVM. So there's got to be a way to do it, and there is. And the way to do it is, instead of using an ohm meter, we're going to use an ammeter to measure current, and we're going to use a voltmeter, in this case a really good voltmeter, the Keithley, that is capable of measuring volts down into the microvolts. I believe down to the microvolt. So that is, you got to have a really good voltmeter to do this. So I thought I'd start out with explaining how it's going to be done, and I'm going to take a couple of measurements. First, I want to measure the resistance of my new speaker wire, and then I'm going to measure the resistance of some typical speaker wires. And this is just an FYI, curiosity, gee whiz kind of thing. It really shouldn't matter to anybody. You've got a good high quality set of speaker wires. As I mentioned before, you have no troubles with at all really with regard to resistance. I'm just doing this for the experimentation and for my own edification and knowledge, especially since I took the time to go ahead and make this paralleled speaker cable. I want to measure it. I want to see how much I've reduced the resistance. In theory, I know how much it should be, but in practice, in reality, I want to see. So here's how we are going to measure resistance of a speaker wire, which is such a very small value. Ahead of time I've run some numbers, and I've come up with a system where I'm going to need a power supply, and I'm going to need an inline resistor to limit the current, and then I'm going to connect in, and I'll just draw a little coil here, but it's not a coil, it's a speaker wire to be measured. So doing that, I've come up with 2 volts, and I had on hand a 3.3 ohm resistor. Now, at a dead short, at a dead short, we should come up with the current, when I say at a dead short, with no speaker wire hooked up or no resistor hooked up here, we should have a current flowing through this circuit of 2 volts divided by 3.3 ohms, and that equals 0.606, a little more than half an amp. And that's fine. My 3.3 ohm, and this 3.3 ohm is merely in the circuit to limit the current. And you'll see that in a minute. So this resistor happens to be a 6-watt resistor. So if I'm going to be passing a continuous DC 0.606 amps through there, how many watts will I be dissipating? Well, I squared times R. So it's going to be 0.606 squared times 3.3 ohms, and that's going to be 1.2 watts. So well within the power handling capability, dissipation capability of the resistor. Now, how are we going to measure current of a speaker wire? Okay, so I just wanted to get that nice little steady state 0.606 amps flowing through there. And then what we're going to do, redraw the circuit, is we're going to put an ammeter in series to measure the current that's going to be flowing. Then we're going to hook up the speaker wire like that to the circuit in series with the resistor and the ammeter. And then we're going to take a voltage using my Keithley voltmeter, which is highly accurate. That's science grade instrumentation right there. So I'm no problem at all getting an accurate millivolts reading. And so we have our speaker wire here. We want to know the resistance, and it's going to be pretty straightforward, right? The resistance is going to be the voltage dropped across it. It's going to be in millivolts probably, or microvolts, I'm not sure yet, divided by the current. And we're going to measure the current directly from our ammeter, and we're going to measure the voltage from the Keithley. And that's how we're going to do it. So let's get started measuring my paralleled speaker cable. And I've got the ammeter hooked up. There's the Keithley hooked up, and basically to trace the circuit. So this is going to be our voltage, our DC voltage source. I've already preset it for 2 volts. So from the positive, we come to one side of that's the resistor right there, the 3.3. Then we go to the probe, the positive probe to the ammeter, and it's set to amps. Then we go from the negative side of the ammeter, right there, to the first side of the speaker wire, and then the second side of the speaker wire comes out right here and goes back into the negative side of the power supply. And then I've got the Keithley hooked up directly across the leads of the speaker wire to get that millivolts. So let me go ahead and turn on the power supply, and hopefully a fuse doesn't blow. And I've got it preset to 2 volts. And let's take some measurements. No need to let anything warm up, it's good to go. So 0.605 amps, and we have 0.0058, 5.8 millivolts. So let's run those numbers just to draw it out here. R is going to be equal to 0.0058 divided by 0.605, and we can take this out to 3% precision of 3.00, really 2, but 58 divided by 0.605 equals let me put it down here, 0.0096 ohms. So there you have it. My new speaker wire, 0.0096 ohms. Now I'm going to replace the speaker wire with the speaker wire that I was previously using, the actual one that I was using between the AS1100 and the Klipsch, which is on the floor right there. And let's go ahead and it's gonna hit pause and take a minute to finagle that speaker wire into this circuit, and then we'll measure that resistance. And by the way, that is a standard typical, I believe that's a 12 gauge. Yep, it's 12 gauge. And it's about it's a little longer than I needed it. This is about 8 feet, but I liked when I was experimenting with the speakers, I was moving them all around into different positions, so I needed something a little longer just to get those different positions. Okay, all right. So now I've got one run of the speaker wire that I was using, and flip my, I'll just waste paper here, I'll just do it up in the right corner. So let's take our I and our V. So our I is 0.600 amps, and our V from our Keithley is 28.4 millivolts. So our resistance of the speaker cable or wire that I was using, 28.00284, I don't need to that precision, 0.006, oh, what am I doing, not 0.006, 0.600, and let's see. I did something wrong. Look at what I did wrong right here. That's wrong. 28.4 millivolts is 0.0284 divided by 0.6. Okay, that's what I did wrong. Decimal place. 0.0284 divided by 0.6. 0.0473, so 0.05 R equals 0.05 ohms. So my previous speaker cable, 0.05 ohms per run. Yeah, but we're comparing one run to one run, meaning a positive cable or a negative. And so I went from 0.05 to 0.0096. So that's a significant reduction in resistance. Let me go ahead and turn this system off here. Now the question is, what effect will that have on reducing the system damping factor, which was in essence my entire goal here, even though it wasn't necessary. But let's start out with what the system damping factor was on my AS1100 using that previous cable, the 0.05 ohm. Alright, so 0.05 ohm versus the 0.0096. Okay, so the first thing I need to do is to determine. I'm going to be running this with my relative to my AS 1100 Yamaha, which has a spec'd out damping factor of 250, it says or more, so that's the minimum it would be, at 8 ohms and 8 ohm load. So damping factor equals, in a perfect world with no resistance, the way it's spec'd out, would be the, I'm going to, instead of impedance Z, I'm just going to draw it as R. So it would be R speaker divided by R output of the amp, right? So I'm looking to find, I want to find R out, so that's going to be R speaker divided by damping factor equals 8 divided by 250 equals 0.032. I'm going to need this for the rest of my calculations right here. So the output impedance of the Yamaha AS11 is 0.032. That would be the maximum output impedance. It might even get lower than that because they spec the damping factor at minimum 250, right? Now, let's do my system damping factor with the speaker cables inserted. So it's the same equation, except this we have to add to it R speaker wire times 2. So, given our 0.05 ohm speaker wire, we have 8 divided by 0.032 plus 2 times 0.05 equals, and I'm just going to run the whole thing, 60. Is that right? Boy, I better run those numbers again. Hang on a second. Well, that's right. So I've taken that beautiful damping factor of 250 in the perfect world, and I've reduced it to 60, which is still a respectable, plenty fine number, but boy, that's quite a reduction just using my 0.05 ohm speaker wires. This guy right here, which is my 12 gauge, roughly 8, maybe 9 foot run. Now, let's see what improvement, and clearly is going to be an improvement, what improvement I'm going to get with my, there it is right there. Look at that ugly thing. Hideous looking. I just made this yesterday, and I made 4 of them, by the way. 1 for each positive, 1 for each negative. I haven't put a spade lug on the end of it yet. I'm going to have to order those. And I paralleled 4 plus and minus pairs for a total of 8. So I've basically taken 8 of these and put them in parallel, essentially, to get my 0.0096. So what is our system damping factor now, or what will it be with the new cables? Well, it's going to be 8.032 plus 2 times 0.0096. And give me a sec, run that number, 0.0096 times 2 equals plus 0.032 equals 1 over that times 8, 156. So, I'm happy with that. So look at that. We've taken, before I had a system damping factor of 60, and I've upped it to 156, which is way, way overkill. But hey, that was my intent, to see if I could notice any audible difference in bass response or otherwise. So I seriously doubt it, but hey, it's going to be peace of mind knowing that I have this ultra low resistance speaker wire. Now you can see we started out with the 250 right here, but what if your amp, and again, you know, there's some debate about what damping factors should be the minimum, and many people on the web say 50. I've seen some say 20, but many say 50. Well, what if you're starting out with an amp that has, like, such as my AS1000, which I love, it starts out at a 40. So let me do the not AS, it's A1000 amp. Starts out at a 40 at 8 ohms. So what effect will this have? Okay, let me run that number. Oh, actually, I need to calculate the output impedance of that amp. Hang on a second. Okay, so I was just running these numbers. So with the A1000, great amp, we're starting out with a damping factor of 40 at 8 ohms, and so I calculated that it has an output impedance of resistance of 2 ohms. So running our system damping factor, it reduces that 40 down to 27. Now that we're talking about my old 0.05 ohm cables. So what about my new 0.0096s? I'm not going to write it out. I'm just going to run the numbers right here and see what I get. So 0.006 times 2 equals plus 0.2 equals 1 over that times 8, 37. Okay, so with my 0.0096ers, I only take my damping factor from 40 to 37. That's what I was looking for, instead of from 40 down to 27, which is a territory I'd rather not be in, mostly for peace of mind. So that was mainly what I wanted to see, what I wanted to hear from myself, perhaps, if there's any difference whatsoever, using my massively paralleled cable. And there you have it. And that is also how to measure the resistance of a low resistance source using a voltmeter, a DVM. Because again, you can't use the ohms resistance setting on a DVM. It just doesn't go that low. It's not accurate enough. So enough of that. I'm going to get these cables, my new cables, hooked up into the system. I'm going to start out listening to the AS1100 and then start switching amps. But there you have it. Another almost pointless video. But I was in the process of doing this stuff myself, so I figured I might as well film it. And yeah, who knows, someone might enjoy this stuff. But anyway, now I'm finished with this project. I'm going to get back to the review of the R9, Yamaha R9 receiver, which of course also has an auto class A mode as well as a tone bypass. And I've already done the bench testing of that. The THD was a tad bit higher than I thought it should be. Still well below 1%, but just a tad bit higher. But everything else measured out fine. Everything's in good working order. So now it's... And I have been listening to it a little bit, but I subbed back in my AS1100 into the system for a while, and I want to get used to that again. Then I want to switch directly to the R9, and then finish up my listening impressions and finalize my review of the R9, basically. So enough of that. Thanks for watching. And by the way, you know, there's, as far as test gear goes, if you have a test bench. And you know somewhat how to use some of this stuff. This is all, I have a lot of inexpensive, well, cheap stuff like this, but this Keithley right here is just invaluable. I love it. They're very expensive. I think these things, this Keithley is a great voltmeter, a great ammeter, a frequency counter, and many other things, including total harmonic distortion analysis. And if you can find one of these things, especially one that's been calibrated, I know new they go for a lot of money, thousands of dollars, $5,000, $6,000, maybe more. I don't know, I forget. But if you watch eBay every now and then, you can pick one of these up for a really good price. I can't remember exactly what I paid for this, but it came from a company that, and I don't know why they had a couple of them on hand, and they calibrated it too. The next calibration is due in 2018, but when I bought it, it was calibrated. And I think this thing was like in the order of $600, somewhere in that realm. I mean, you know, just an astonishing bargain. And so if you can find one of these things, and you can use it as your voltmeter, your frequency counter, your THD, and it does many other things. I haven't even read the manual for all this other stuff. I only use it for what I need it for, but unbelievable. And of course, you need a good audio generator, if you're going to do THD measurements, you need to start out, I'm on a tangent, huh? You need to start out with a source of low THD, and at a good price. This guy right here, this GW Instack, if that's how you pronounce it, this audio generator, it's an initial source of low THD sine waves, and you can't get that kind of low THD with a function generator such as that one up there. You know, you have to have an audio oscillator built into that thing. Function generators, the way, I'm on a tangent. Anyway, those tools right there are just invaluable. They're fantastic, as well as a good scope such as this Tektronix. This is a 1052B. Does everything I needed, and it's a very low cost scope. These things are really made for students, high school or college students getting into electronics. But excellent stuff. Highly recommended. Anyway, thanks for watching. Ciao.